Hello guys, this is Akash. Welcome back to Nursery with Lecture YouTube channel. In this video, I'm going to explain the conic sections, that is ellipse and hyperbola. I already explained the circles, parabola and straight lines and pair of straight lines, which are the part of the geometry. In this video, I will explain complete ellipse and hyperbola in one shot, so that you can understand how important this video can be, because the ellipse and hyperbola can be treated as a separate chapters, but these are related in my perspective. So I have explained this in a one shot. So listen carefully guys and watch till the end, and if you didn't subscribe to this channel, subscribe to this channel, because very important updates are going to come in the upcoming videos, so that you have understand how important this section is. So this JEE 2024 Elevate batch is for only dedicated JEE 2024 aspirants, because in this thing what I explained, the main important concepts which are having the high weightage after the new syllabus arrival, so that I have explained everything, so that you have to understand how important this series is. So the main important thing is you have to follow this series, and I hope you will be going to follow every video, and in this video I'm going to explain the ellipse and hyperbola. First of all, what is an ellipse and what is an hyperbola? I will explain entire hyperbola and I will explain parabola. So hyperbola I will left this one, so it is not bad feeling. Yes, I will explain ellipse first, because ellipse is the first thing before parabola. If you understand ellipse, it is very easy for hyperbola. So what is ellipse first? I already discussed eccentricity. What is eccentricity? The distance between the point on a curve to the to the directrix, and the ratio of the same point with the distance of the focus. That ratio, that is, if I define the point as P, and the distance from the directrix if I defined as D, and if I define the distance of a point from the focus is F, if this ratio is less than 1, that is in the this is ellipse, and there are two focuses, that is S1 and S2, and these are the directrix. That is, if this is a point, the distance of the point from the directrix, or you can say not this one, this distance and this distance, if I take the ratio, if this distance is less than 1, then it is called as ellipse, and if this distance is greater than 1, then it is called as hyperbola. So up to now you have to understand this one only. Now I will explain the entire ellipse, that is, what are the properties, what are the tangent and normal equations. I think this session will be a 1 hour, so that you can think how will be this much concise a video can be, because the ellipse and hyperbola we can discuss up to 5 hours, 6 hours and 8 hours, but there is no point, because this chapter having only +4 weightage, and if the weightage having the +4, we have to focus on only main topics. There is no need to discuss the high difficult topics here. So that I will discuss what is needed. 1 second guys, I will open the PPT so that I can understand what are the things I should explain. Yes, now starting the actual ellipse. So I will take two equations parallelly. There are two types of ellipse. What is the first ellipse? The ellipse equation is x square by a square plus y square by b square is equal to 1. And the another ellipse which I am going to discuss is x square by a square plus y square by b square is equal to 1. Why there are two same equations? The reason here is, in one ellipse the a will be greater than b, and another ellipse the a will be less than b. What is a and b? That is, I will draw the ellipse here. I will draw the ellipse. If you observe, the points here is a comma 0, and this point is minus a comma 0, and these two are the directrix. And if you observe the focus, this is S2 focus, this is S1 focus, and the focus here are S1 comma S2, where S1 is minus ae comma 0, and the S2 is ae comma 0, and the directrix equation is x equal to a by b, here a by e, and here x is equal to minus a by e. That's it. X equal to a by minus a by e, x equal to a by e is the main important thing here. 1 second, guys. Yes, guys, sorry for the interruption. This is S1 and S2, that is minus a comma 0. This is a comma 0, and this x is equal to a by e, and this x is equal to minus a by e. That's it. Now comes the important, how to calculate the eccentricity. And this ellipse, how it looks like. This is the vertical ellipse. This is a vertical ellipse, and if you think the points, it will be 0 comma b, and here if the point is 0 comma minus b, and this a, this is a distance. This is a a, this is a a. Entire distance is equal to 2a. And this 2a is called major axis. Major axis in case of this one, and this length is 2b, because this is the point 0 comma b, and this point is 0 comma minus b. So this distance is 2b. So 2b is the minor axis. But here the scene will be reversed. Here the minor axis will be, this is the length is 2a, and this length is 2b. This entire length is 2b. And these are the directrix equations. And what are the focus equations? That is 0 comma be, and 0 comma minus be are the focus equation. That is the focus points. And what is the directrix equation? The directrix equation is equal to y equal to minus that is y equal to b by e, and here the directrix equation is equal to y equal to minus b by e. These are the things you have to understand. Here in the first ellipse, the major axis is 2a, but here the major axis is equal to 2b now. The major axis here is equal to 2b. Major axis is equal to 2b. Yes, and the minor axis is equal to 2a. That's it. Now comes the important thing, that is the calculation of the eccentricity. Here the b square is equal to a square into 1 minus c square is a relation. But here a square is equal to b square into 1 minus c square is a relation. You have to observe, when a is greater than b, we have to use this relation to find the eccentricity. But when a is less than b, we have to use this relation to find the eccentricity. And here the center is 0 comma 0. Yes, here the center is 0 comma 0. That's it. And next thing, what is the vertex? The vertices are plus or minus a comma 0. Yes, here the vertices are plus or minus b 0 comma b. Yes. I think here I can write as 0 comma plus or minus b. Yes. Now I already explained what is the focus, plus or minus a comma 0, and here the focus will be 0 comma plus or minus b. These are the focuses. And what are the directrix equation? Directrix equation is equal to x equal to plus or minus a by e, or the directrix equation. Here y is equal to plus or minus b by e is the directrix equation. And next, if this is an ellipse S1 and S2, suppose this is a point P, and this one, if I join PS1 plus PS2, this distance is equal to 2a. It is very important relation. That is, the point PS1 plus PS2 will be definitely equal to 2a. This is the 2a is the major axis thing. Very important, you have to understand. Now here if you observe, same thing. Suppose in the vertical ellipse, if you observe, there is a point here, and if I join these two, this distance is equal to 2b. Very important. Now I have completed the basic introduction of ellipse. Now let's get into auxiliary circle. What is auxiliary circle? Auxiliary circle is simply if a circle is drawn with considering the major axis as a diameter, this circle is called auxiliary circle. This circle is called auxiliary circle. That's it. And auxiliary circle equation, you know, that is x square plus y square is equal to a square. Yes. And now position of point. Again we got position of point. Position of point with respect to ellipse. So first of all, I will discuss the x square by a square plus y square by b square equal to 1 equation only. For this one, what is s? I already explained the notations. The x will be x by a square plus y by b square, that is y square by b square, minus 1 is equal to 0. This is s. And what is s1? s1 is x1 square by a square plus y1 square by b square, minus 1 is equal to 0. This is s1. And if you observe very clearly, here the main important thing, that is same with the help of S1 value, whether it is 0, whether it is greater than 0, whether it is less than 0, we can decide whether the point is inside, on, or outside. Suppose this is ellipse, the point can be on, it can be in, it can be out. So when S1 is equal to 0, it is satisfying the ellipse, so it is on the ellipse. It is on the ellipse. And when S1 is greater than 0, we will get outside. And when S1 is less than 0, it is inside the ellipse. Yes. Now position of line. I discussed the point. Now let's discuss the line. What is the line with respect to ellipse? Suppose this is ellipse. This is a line. This can be a line. This can be a line. What is the difference between these three lines? This is non-intersecting. This is non-intersecting. This is a tangent. And this is a intersecting. So there are three possibilities in the ellipse, that is non-intersecting, intersecting, and tangent. So now when will be the intersecting? When a square m square plus b square value greater than c square, and a square m square plus b square value is equal to c square, and a square m square plus b square is less than c square. If these three are the conditions, when first thing a square m square plus b square greater than c square, here it will be intersecting. And when it is equal to 0, it is tangent. And when this is less than c square, a square m square plus b square value less than c square, it is non-intersecting. This thing you have to remember. This is non-intersecting. And one more important thing, that is a square m square plus b square greater than c square. Yes, it is not. It is intersecting. Yes, I discussed. And when, if you observe, that is a square m square plus b square equal to c square, what is the tangent equation? Suppose y equal to mx plus c is a tangent equation. So from this, what I can write? Y is equal to mx plus root of a square m square plus b square is the tangent equation in slope form. I will discuss the tangent equation once again. This is the thing. And there is a relation. Suppose this is the thing. And one more thing, that is x square by a square plus y square by b square is equal to 1. What are the parametric coordinates? The parametric coordinates can be a cos theta comma b sin theta. Yes, a cos theta comma b sin theta. Yes. So suppose if I assume like this, and if I give the 2 points, suppose this is P point I will give, and this is Q point I will give, and this is the focal chord. Suppose it is joining the focus. Suppose this chord is joining the focus, and in order to find the equation, what I can do, this is I can take it as alpha, and this as beta angle it is making. Yes, that is a parameter I am saying, not the angle, it is the parameter. With the equation, what I can do, I can write this equation as x by 2 cos of alpha plus beta, x by 2 cos of alpha plus beta by 2 plus y by x by a cos of alpha plus beta by 2, then y by b cos of I think it is sine. 1 second guys, there is an error. 1 second, I will again write, that is x by a cos of alpha plus beta by 2 plus y by b sine of alpha plus beta by 2 is equal to cos of alpha minus beta by 2. Yes, this is a thing. Equation of tangent. Now let's discuss the equation of tangent. What is the equation of tangent? In the point form, first I am discussing. The point form is very easy. Anyone can write. That is, I already discussed what is the x notation. That is x square by a square minus y square by b square. That is plus y square by b square minus 1 is equal to 0. Now what is the equation of the tangent in the point slope? That is, we have to replace x square is equal to x x1, and y square we have to replace y y1, and x we have to replace x plus x1 by 2, and y we have to replace y plus y1 by 2. Yes, simply substitute this one. S is equal to x x1 divided by a square plus y y1 divided by b square minus 1 is equal to 0. This is the tangent equation at the point of contact x1 and y1. This is the slope form, that is the point form. Now let's discuss the parametric form. What is parametric form? Simply substitute the value of a cos theta comma b sin theta as the point in this equation. What you will get? X into a cos theta divided by a square plus y by b square into b sin theta minus 1 is equal to 0. What you will get? You will get I think x by a cos theta plus y by b sin theta minus 1 is equal to 0. So this is the answer. Now slope form. I already discussed the slope form. That is slope format. What is the slope format equation? That is y is equal to mx plus y equal to mx plus or minus root of a square m square plus b square. This is a slope format answer. And what is the point of contact here? In the circle, I will explain. I have explained that is the point of contact is plus or minus a square m divided by a root 1 plus m square and minus or plus that is plus or minus a square m by c comma minus or plus. I think it is a square by c. I think yes, it is the point of contact. But here the point of contact changed. The point of contact here is minus a square m divided by c comma plus b square by c. There is no. I think this is the main important thing you have to understand. The point of contact here you will get 4, but here you will get only 1. That is minus a square m by c comma. Here if you take minus, that is minus a square m by c comma plus b square by c. That's it. What is c here? C is this value. That is c is equal to root of a square m square plus b square. That's it. Now let's discuss the equation of normal. Just remember the equation. There is no need. For anything. Just remember the equations. Because this is not the time to go depth. This is the time to revise the things. That's it. Equation of normal. Now let's discuss the point form. Point format. What is the point format equation? A square x divided by x1 minus b square y divided by y1 is equal to a square minus b square. This is the equation of normal in the point form. Yes. Yes. And next is parametric. Parametric is ax divided by cos theta minus by divided by sin theta is equal to a square minus b square. This is parametric. That is ax by cos theta minus by sin theta is equal to a square minus b square. Or you can write ax secant theta minus by cosecant theta is equal to a square minus b square. That's it. Now slope format. Very important. It is slope. That is slope form. The slope form is y is equal to mx plus or minus m into a square minus b square divided by root of a square plus b square m square. That's it. This is the slope form equation. That is a normal equation in slope form. That is y equal to mx plus or minus m into a square minus b square divided by root of a square plus b square m square. That's it. Again here also director circle. Suppose this is an ellipse and this is a point. In this point I have drawn the two tangents. Suppose this is a point, I have drawn the two tangents. If this is the tangent where we got the perpendicular, and with the help of this, if I draw the circle, this entire circle is called director circle. This entire circle is called director circle. Yes? This entire circle is called the director circle. And there are some common results we already know. What are the common results we have discussed in the up to now in the circles parabola? Here also they will repeat. What is the chord of contact? Chord of contact. Chord of contact is equal to, what is the chord of contact? It will be t is equal to 0. Yes. And next one is chord with given midpoint. Chord with given midpoint. Chord with a given midpoint. What will be the answer? A chord with a given midpoint will be t is equal to s1. Yes, the chord with a given midpoint is equal to t equal to x1. I already said what is t is equal to 0, and I already said what is t is equal to s1. And the pair of tangents. These results you have to simply remember. That is pair of pair of tangents equation. It will be s into s1 is equal to t square. Okay, I will explain the s, t and s1 and t square, because you have to understand how important it is. It will be x square by a square minus y square, that is plus y square by b square minus 1 equal to 0. This is the s notation. And s1 is equal to point substitution, that is x1 square by a square plus y1 square divided by b square minus 1 is equal to 0. And what is t? T is a transformed equation of this, that is x1 divided by a square plus y1 divided by b square minus 1 is equal to 0. Yes, that's it. And we came to the end of ellipse. That is we will discuss the properties. That's it. Properties. The properties of ellipse. Yes, what are the properties? The first properties. The statement is like this. I will explain, and later you can understand. The portion of the tangent to an ellipse between the point of contact and the directrix subtends a right angle triangle at the corresponding focus. Very important. I will draw the diagram. Suppose if I draw, one second, it is not coming what I expected. One second. This is a line. What they are saying, this is a directrix. Yes, what they are saying, the portion will subtend a right angle triangle at the focus. This is a right angle. This is a right angle. This one they are saying they will subtend the right angle triangle at the point of contact P. That is, the right angle triangle will be at the focus, that is S1 and S2. Here the right angle triangle will be there. When the portion of the tangent, this is a portion of a tangent and it is subtending the right angle at the focus, and this is the portion of a tangent between the point of contact and the directrix. These two, this one and this one. These two are the directrix equations. These two are the directrices. So when the portion will subtend the right angle triangle at the focus, here also the right angle triangle will be formed between the portion and the lines which are joining the focus. Very important. This is the first property. And the second property is the tangents at the extremums of the focal chord intersect on the directrix. Very important. That is, suppose this is S1, this is S2. If I draw the focal chord, this is a focal chord. If I draw the tangents, they will intersect at a directrix. This is a property. When I draw the tangents at the extremums of focal chord, this is a focal chord. This is the focal chord. So when I draw the tangents by using the extremums of the focal chord of the ellipse, they will intersect at the directrix. And the third one, that is feet of perpendiculars from foci on any tangent. This is very important. It came in the JMIN's 2021 paper. What they are saying, suppose this is an ellipse. This is an ellipse and this is a tangent. What they are saying, this is S1, this is S2. The feet of perpendicular, this feet of perpendiculars product, suppose this is P1 and this is P2. This product P1 into P2 will be is equal to B square. What is B? B is x square by a square plus y square by b square is equal to 1. This B square. Yes, this is again the property. The product of the length, this length, feet of perpendicular lengths, this product P1 into P2 will be is equal to B square, which is the square of the half of measured distance. That is which is the measure that is minor axis. Because if you think this is a ellipse, this is B, so this square B square is the answer. Yes. Now comes the reflection property. Reflection property is very important because the questions have came. Very important. I will explain. This is ellipse. What they are saying, rays emanating from the focus of the ellipse from one focus of the ellipse, after reflection from the ellipse, they will pass through the second focus of the ellipse. Suppose this is S1 and this is S2. What they are saying, suppose there are rays emanating. Suppose the rays are emanating. After striking the surface, they will pass through another focus. This is a property. Another focus on the ellipse, and the tangent and normals at the point. Suppose at this point, if I draw the tangent, and normal, if I draw the tangents and normals at the point P, then one second. I think I can draw the diagram better. This is ellipse, this is S1, this is S2. Yes, the rays emanating from one end will strike and moves to other end. Yes, this is the main thing. And they are saying that the tangent and normal at the point P on the ellipse bisect the internal and external angles between the focal distances of P. This is P and the tangent, this tangent and the normal, these are bisecting the angles between these lengths. This is a reflection property. These two are bisected. That is, the external angles have been bisected. That's it. Now the ellipse is completed. Ellipse completed. What you have understood in the ellipse? I have discussed the ellipse. What is the ellipse equation? What is the main conditions? How there are two ellipses, that is when a is greater than b, it is x square by a square plus y square by b square equal to 1, and when a is less than b, it is also x square by a square plus y square by b square equal to 1, but there is a change in the values of a and b. And what is eccentricity relation for first ellipse? That is b square equal to a square into 1 minus c square. What is the ellipse? That is a eccentricity relation for second one. It is b square. It is a square equal to b square into 1 minus c square. Now comes the important thing. That is for the first ellipse, the major axis is 2a, but the second ellipse, the major axis is 2b, and the minor axis will be here 2b, and here it is 2a. And what is our slope format, and that is a point format, parametric format, slope format. What are the tangent equations of ellipse? And for the normal, for the finding the equation of the normal, what is the slope format, and what is the point format, and what is the parametric format? These 6 formats you have to learn, so that definitely you will be going to make +4 marks. Very important. Now I will discuss the hyperbola. Now let's discuss the hyperbola. The hyperbola, here also there are 2 types of hyperbolas. That is a hyperbola 2 types. That is x square by a square minus y square by b square is equal to 1 is the one type of hyperbola, and x square by a square, and hyperbola looks like this. You already know. This is the hyperbola. These are 2 are the directrix, and this is the hyperbola. These 2 are the 2 branches of hyperbola. Yes. Now I will write the equations of the 2. So the first equation is x square by a square minus y square by b square equal to 1, and here this is a normal hyperbola. Now this is a conjugate hyperbola. What is the difference? The conjugate hyperbola is x square by a square plus y square by b square is equal to 1. I think here it is minus 1. X square by a square minus y square by b square is equal to minus 1. You can think like this. This is the equations. These 2 are the equations. And now calculation of eccentricity. What is eccentricity? E equal to root of 1 plus b square by a square is this eccentricity. And what is this eccentricity? It is, I think it is 1 plus a square by b square. Yes, the reverse. Here it is b square by a square. Here it is a square by b square. You have to think like that. And what is the center here? This is a hyperbola like this. the center will be 0 comma 0. Yes, the focus is a comma 0, and here also minus a comma 0, and directrix equation is equal to a by minus a by b here, and here it is a by b, a by e plus a by e. And here the major axis, minor axis, there is no major axis, minor axis, there is transverse axis. This is called transverse axis, and this entire axis is called conjugate axis. Yes, the transverse axis length is 2a and the conjugate axis length is 2b. Here also there the hyperbola looks like this, and these two are the lines. Yes, if you observe very carefully, this is 0 comma be and this is 0 comma minus be, and these are the points you already know. And here the transverse axis length is 2b, but the conjugate axis length is 2a. You have to understand. Here we will find the difference of the point. Suppose this is a point x1 comma y1. If I join the focus like this distance, entire distance, this is s1 and s2. What is the relation? That is p s1 minus p s2 is equal to 2a. Very important. In the ellipse, what we learned ps1 plus ps2 is equal to 2a we learned, but here it is opposite. That is the difference here will be 2a. And one more thing, 1 by e1 square plus 1 by e2 square is equal to 1, where e1 is the eccentricity of normal hyperbola, this one, and e2 is the eccentricity of conjugate hyperbola. If both the eccentricity, if I calculate and square and reverse them, the sum will be is equal to 1. By using this relation, you can find the eccentricity of if one hyperbola is given, and we can find the eccentricity of another hyperbola. It is very, very, very important. And now auxiliary circle. Again, we know what is auxiliary circle. If this is a hyperbola, by taking the reference of these points, by making the diameter, we can make one circle, this circle. This circle. Yes, this circle is called auxiliary circle. Auxiliary circle. And what is the equation of circle? Say x square plus y square equal to b square, that is a square. Yes, and what is the parametric coordinates of ellipse? X square by a square minus y square by b square is equal to 1. So here the parametric coordinates can be a sec theta can be b tan theta. Yes, this is a thing. Now I will discuss the position of point. Position of a point with respect to hyperbola. What is the position of a point with respect to hyperbola? This thing you have to understand. This thing you have to understand. What is the position of a point with respect to hyperbola? The point can be, here you have to understand, this is the hyperbola. This is hyperbola, and suppose the point is like this here, and here it is called inside, it is called outside, and this is called on the hyperbola. Now comes the important point. I already said what is its notation? X square by a square minus y square by b square minus 1 is equal to 0. This is the S notation. And what is S1? The point substitution. Suppose this point is p x1 comma y1. The point will be x1 square by a square minus y1 square by b square minus 1 is equal to 0. This is S1. With the help of the S1 value, we can decide whether S1 is equal to 0, S1 greater than 0, S1 less than 0. When S1 is equal to 0, it is very clear, it is on the hyperbola. It is on the hyperbola. But when S1 is greater than 0, in the remaining all cases, circle, parabola, and ellipse, what we discuss, when S1 is greater than 0, the point will be outside. But here, when S1 is greater than 0, the point will be inside. It is very important. This thing you have to remember. There is a difference from the rest of the curves. It is inside point. And when S1 less than 0, it is outside point. Very important. Understand? This is the position of point. Now, position of line. What is position of line? Same. Same thing, the position of line, this is the hyperbola. It can be tangent, it can be intersecting, or it can be nothing, that is it is something else. Suppose it is not meeting, so it is, there are three cases, that is intersecting case, intersecting, non-intersecting, non-intersecting, and tangent. Yes, so if you observe carefully, it is intersecting, non-intersecting, intersecting, non-intersecting, and tangent. And this intersecting, non-intersecting, and tangent, if you observe carefully, what are the conditions it will give? It will give when c square is greater than a square m square minus b square. It is intersecting. When it is a tangent, when c square is equal to a square m square minus b square. When c square less than a square m square minus b square, it is non-intersecting. If you observe carefully, when a square m square plus b square less than c square, there we got here. Once again, here, when a square m square plus b square less than c square, when c square is greater, here we got non-intersecting. Non-intersecting. Here, when c square is greater than, we are a square m square minus b square, we are getting intersecting. There we got non-intersecting. So you have to remember. So the position of point is line is completed. Now we will discuss the important thing, that is equation of tangent in various forms. After discussion of equation of tangent, we will discuss the equation of normal. So what is equation of tangent? The equation of tangent will be, first thing we will consider the point form. The first form is point form. So in point form, if you observe, the equation is x square by a square minus y square by b square is equal to 1. Yes, the point form will be x1 minus a square minus y1 by b square minus 1 is equal to 0. Yes, and the parametric form will be parametric form. In parametric form, what we have to do? We have to substitute the point, that is a sec theta comma b tan theta, we have to substitute. When we substitute, what we got? X by a secant theta minus y by b tan theta is equal to 1. And third one, it is slope. Slope form we already know. In the slope form, we already know what is the condition, that is y equal to mx plus or minus what is c condition? C square is equal to a square m square minus b square. So c equal to root of a square m square minus b square. Yes, root of a square m square minus b square. This is a slope form. And the tangents are completed. Now normals. The tangents are completed. Now we will discuss the normals. Now we will discuss the normals. Very important thing. In the normals, we have to take care of the slope form because it is very important. In the normal, the point format is that is a point. Point form is a square x divided by x1 plus b square y divided by y1 is equal to a square plus b square. If you observe carefully, only this equation, a square x divided by x1 minus b square divided by y by y1 is equal to a square minus b square. This is the equation of normal in the point form for ellipse. This is hyperbola. You can compare both. Why I discussed it in only one video? Because you can compare the equations. In the place of b square, if I substitute minus b square, then it becomes the equation of hyperbola. Here, if I substitute, that is, if I substitute b square as minus b square, I will get a square plus b square, which is the equation of normal in the point form for hyperbola. This is the point form. Now we will discuss the parametric. Parametric form. In the parametric, just substitute the value, that is a sec theta comma b tan theta. When you substitute this answer, what you will get? You will get a square x divided by a sec theta yes So here I think a will get cancelled, b will get cancelled. So ax by sec theta plus by tan theta is equal to a square plus b square. Yes, this is the answer in the parametric form. Now discuss the slope form, which is very important. Slope form. Same, y is equal to mx plus or minus m into a square plus b square divided by root of a square minus b square m square. Yes, in the place of b square it is b minus b square. Yes, because this minus b square is a ellipse and plus b square is a hyperbola. That's it. So this is a slope. So I have discussed the tangent and normals. Now let's discuss the important thing. The important thing is a director circle. Director circle. What is the director circle? The director circle is nothing but, suppose this is the hyperbola. Suppose if I at the external point, if I draw tangents, if it meets at 2 points, suppose if it meets 2 points and this intersection is perpendicular, suppose assume if it meets the perpendicular and if you join this and draw a circle, suppose assume this is a circle, this circle is called director circle. This circle is a director circle. Just remind the diagram. I think it is wrong or right, anything, leave it. Main, what is director circle? It is a locus of the tangents which is perpendicular, which is drawn from a fixed point that is outside of the curve. That is, when we draw the two tangents and those tangents having the intersection point as 90 degree and with the respective point, if I draw the circle, that circle will be director circle. And here the director circle equation is x square plus a square is equal x square plus y square is equal to a square minus b square is the equation of director circle in case of hyperbola. Very, very, very important. Now let's discuss the common topics. Now let's discuss the common topics. What are the common topics? I already discussed so many times in the circles, parabola, ellipse also discussed. Now in hyperbola also. What is the chord equation? T equal to 0. What is the chord with a given midpoint? T is equal to x1. What is the pair of tangents? It will be ss1 is equal to t square. That's it. This is chord. This is chord with given midpoint. Chord with given midpoint. And this will be pair of tangents equation. These three are all equations only. Yes, you can think like this. And now asymptotes, very important topic. Asymptotes. What is meant by asymptote? Asymptote is nothing but, simply remember, it is tangent at infinity. Tangent at infinity point contact. This is the point of contact at infinity. Suppose this is the hyperbola. If you assume this is a hyperbola, and if I draw the tangent like this, these tangent will meet the hyperbola at infinity positions. If this is the thing, this line which is a tangent is called asymptote, because it is a intersection at asymptote. Yes, this is asymptote. Now very important, tangent at infinity, we know that y is equal to mx plus or minus I think it is root of a square m square minus b square. Yes, this is the equation of tangent of the slope form. Yes, now they are saying it should be at infinite. That is the thing, the point of contact is infinite. What is the point of contact? The point of contact for this one is a square m by c comma b square by c. Yes, so if in order to make the point of contact infinite, here c should be 0. So what is c? C will be a square m square minus b square should be equal to 0. So if you think like this, a square m square is equal to b square. So m square is equal to b square by a square. So m is equal to plus or minus b by a. And when I back substitute, I will get equations as y equal to plus or minus b by ax. So y is equal to b by ax and y is equal to minus b by ax are the two asymptotes for the equation of hyperbola, which is x square by a square minus y square by b square is equal to 1. That's it. This is asymptote concept. And if you think like this, x square by a square minus y square by b square is equal to 0. Very important. This is the equation of pair of asymptotes. Pair of asymptote. Yes. It will be the equation of pair of asymptote. Now very important. This is hyperbola. This is its conjugate hyperbola. If I draw the things, you will observe hyperbola and its conjugate will have same asymptotes. You can observe in the figure. Very important. One second, guys. Properties of hyperbola will be similar to ellipse only. So you can revise there in the what I discussed in the ellipse. In this video only you can replay the video and see the properties which are same as ellipse. There is ellipse and hyperbola properties are somewhat similar, but I will explain the important concept here, that is rectangular hyperbola. What is meant by rectangular hyperbola? The rectangular hyperbola is a shift of the hyperbola. This is called rectangular hyperbola. Yes, the turning of rectangular hyperbola. That is the turning. The actual hyperbola looks like this. If I turn the axis, if I rotate the entire thing, I will get this thing. It is very, very, very important. Just I have rotated this. Yes. And for this, the length of conjugate, length of transverse and conjugate axis will be equal. Length of transverse and conjugate axis will be equal for rectangular hyperbola. Length of transverse and conjugate axis will be equal for rectangular hyperbola. Now, if that is the case, x square by a square minus y square by b square is equal to 1. When a is equal to b, they are saying the transverse axis will be equal to the conjugate axis. The x square minus y square is equal to a square. This is a rectangular hyperbola. That's it. And if I generalize this one, I think here the eccentricity will be e is equal to 1 plus b square by a square. But here a equal to b 1 plus a square by a square. It will cancel. So eccentricity will be root 2, fixed root 2 for rectangular hyperbola. For rectangular hyperbola, what is eccentricity? If it is asking the JEE mains, you have to just report it is root 2. But they will not ask like that. They will give you a question where you have to use the eccentricity of rectangular hyperbola. And the asymptotes of the hyperbola is, you already know, y equal to plus or minus b by ax. But in the rectangular hyperbola, y is equal to plus or minus, both are equal. So y is equal to plus or minus x, or the or the asymptotes. Now let's discuss the rotation of axis. Rotation of axis. If this is a rotation of axis, you already know what is x dash. X dash equal to, I have rotated the axis by 45 degree in order to get the rectangular hyperbola. So by root 2, you have to remember this table. I already discussed x y, x dash y dash, cos theta minus sin theta, cos theta. Because of this, they have written like this. X dash is equal to this one. 1 second. I will verify it. It is cos theta minus sin theta. Yes, I have written same. Cos theta minus sin theta. Yes, same. There is no difference. Here we are writing x dash. So here y dash will be x by root 2. X by root 2 plus 1 second, guys. So what we got? X by root 2 plus y by root 2. These are the rotation of axis points. And we know x square minus y square is equal to a square. Yes. And by substituting this one, x this values, that is x minus y by root 2, because this is a dash, the new axis, that is x minus y by root 2 minus, that is you can think like this, that is x minus y by root 2, because I am writing this one, x minus y by root 2 into x plus y by root 2, I am writing like this, that is equal to a square by 2. And if I generalize this thing, x minus y by root 2, x plus y by root 2 is equal to a square by 2. If I write this as x dash and this as y dash is equal to, if I write a square by 2, this can be written as xy is equal to c square, where c square is equal to a square by 2. So we have generalized the thing. So xy is equal to c square is a rectangular hyperbola equation. Rectangular hyperbola. Rectangular hyperbola equation. Yes. Now for this hyperbola, for this rectangular hyperbola, you have to understand some points to solve questions in rectangular hyperbola. Yes. What is hyperbola we are discussing? This is the hyperbola we are discussing. This is hyperbola. This is hyperbola we are discussing. And xy is equal to c square is a point. There is a equation. For this equation, first thing is vertex. The vertex is y is equal to x. Here, the vertex is y is equal to x. This is a vertex. And now, this vertex point can be plus or minus c comma plus or minus c. Yes, because xy is equal to c square, we have to represent the point of plus or minus c comma plus or minus c. Why we got like this? Because xy, where the y equal to x line, it is x square is equal to c square. So x is equal to plus or minus c. That is the reason we have taken plus or minus c comma plus or minus c, because x and y are equal. And next, the important thing is focus. What is focus? Plus or minus 2 root c comma plus or minus root 2c comma plus or minus root 2c. That's it. And what is directrix? The directrix equation very important. That is cx plus y plus or minus c root 2 is equal to 0. Cx plus y plus or minus c root 2 equal to 0. Cx plus or minus, that is cx plus y plus or minus c root 2 is equal to 0. This is the directrix equation. Very important. Now comes the parametric coordinates. Parametric coordinates, very important. What are the parametric coordinates for rectangular hyperbola? That is, we got xy is equal to c square. So what I can take ct comma c by t I can take. If I multiply these two, I will get ct into c by t. Tt will get cancelled, I will get c square. So ct comma c by t are the parametric coordinates for rectangular hyperbola. And now comes the important point, that is slope of tangent at parameter. If I discuss the parameter, what I can get mt, that is slope of tangent, is equal to minus 1 by t square. And what is the slope of normal at p? It will be t square, because when these two gets multiplied, you have to get minus 1. That is the reason we are taking like this. That is, slope of tangent will be minus 1 by t square, slope of normal will be t square. Minus 1 by t square, and slope of normal will be t square. That's it. Up to now, I think we have discussed the entire hyperbola. In the hyperbola, I didn't discuss our properties because those properties will resemble the ellipse. And suppose if I want to explain, I can explain. Suppose this is the first property. Suppose I will explain this property only. What it is saying? The property is saying, if I draw the tangents, and if it meets, if I draw the tangent, if it meets, the portion between these two will subtend the right angle, and the portion between these two, this is S1, this is S2, the portion will subtend the right angle. That is this, I think, the focus and this directrix, this thing will be perpendicular. That is a property of hyperbola, which is similar to ellipse only. So now we have discussed the entire hyperbola and ellipse in one shot. I think you have enjoyed the session, and if you have any queries, you can contact me in the comments of this YouTube video. And if you want some more videos like any concept, you can ask me. I will prepare the videos also. But the main important thing is you have to comment down, and what I can improve in my videos you have to say. And after reading all the comments, I will get one analysis, and I will get improved by next videos. It is very important. And if you want any question practice, I am saying I forgot to say, Changemakers batch which I completed in 2023, that is for 2023 JEE aspirants, you can refer the videos of that videos also. I have explained better than now, because that time I have focused highly in concept. I have practiced some questions also. You can rely on them. That is, if you watch the videos, it will be in the playlist section of Nursery with Lecture channel. And in the Nursery with Lecture playlist channel, you can access the videos which I discussed in the previous months. So you can type the hyperbola one shot by Nursery with Lecture. You can type, and you will get the video. And after getting the video, it is very important to skip the starting part, because those is the theory part I already explained in this video. So you can skip that one, and you can relay completely at the last 20 to 30 minutes, because in that time I have explained the complete questions. Not complete questions, I have explained some important questions, like you can think of 5 to 10 questions I have explained. Those questions are really important in order to understand the concept. So that's it, guys. And if you have any other queries, you can comment it down. And one more thing, guys, if anyone didn't join the Telegram group, you have to join the Telegram group, because the Telegram group I am giving the regular updates of the JEE Mains exam, as well as the PDF which I written now. You can access them, and you can find the notes also for different things. I already shared in the before months. You can access them. And one more thing, guys, if you like this video, subscribe to this channel in order to get the notifications. And I hardly request that you have to join the Telegram group. And one more thing, you have to comment down what other things can I bring to you. And if everything is okay, you can like this video and subscribe to this channel to get the notification. That's it for this video, guys. Keep learning, keep going. Thank you.